My name is Alessandro, and I'm the coach of the team for the chair of aircraft design. The team has done an amazing job with some cutting-edge technologies using really cool stuff to solve a rather serious problem. I'll let them tell you all about it, so Ignacio, take it away.
Thank you, Alessandro. As some of you may know, Benin is a West African country. In some regions, entire cities are flooded in water. How the water levels usually increase or decrease depending on the season. These changes in the infrastructure provide the perfect environment for disease proliferation. In order to solve this problem, with the help of a team of students of the Institute of Aircraft Design, which are developing an aircraft to fly over the area. The aircraft is being controlled by a pilot and a mission operator. The aircraft scans the terrain for interesting objects, such as buildings and roads, and highlights this information to the mission operator who's using our application. Let's have a closer look at our system. Our system is composed of a payload attached to the drone, a server for the image recognition, and the iPhone application. The payload sends the frames to the server, while the iPhone gets the GPS and altitude from the radio controller and transmitted to the server. The server uses this information to analyze the frames and returns the labels to be displayed in the application. The server-iPhone communication is done via Wi-Fi. Unfortunately, Wi-Fi was not an option for the payload server communication because of the short distances of this technology. 4G proved to be too expensive and the equipment too heavy and unreliable. So instead, we went with 5.8 GHz video transmitters, allowing up to 1 kilometer range and cheap and small hardware. So let's have a closer look at our payload. Our hardware is composed of a camera, a transmitter, and a battery. One of our main requirements was that the whole payload had to be kept below 200 grams, because this is the maximum weight that the aircraft can carry. Our current payload is 180 grams and allows for around 2 hours of operational time. This is 4 times more than the autonomy of our current aircraft. Here you can see some pictures of our payload. You can see we're using a GoPro Hero 3 as our main camera. In order to fit everything into the aircraft, the students from the Institute of Aircraft Design 3D printed a model of a payload bay for us, where we could fit all our hardware nicely and keep it protected. Now, in order to discuss more about our image recognition, let me introduce you to Victor.
Thank you, Ignacio. So, the image recognition. In our system, we not only want to take a picture and classify what object is in that picture, we also want to say where in the picture that object is. And we do not only want to do it for one object, but for multiple objects. And not only for one frame, but for a video in real time. So as you might imagine, this is computationally very heavy and also requires a lot of data. So where are we getting our data from? Well, we're using OpenStreetMap, and using OpenStreetMap's API, we're extracting the locations of the objects, which is then overlain on top of satellite images. These images are then being fed through a fully connected neural network, which is then combined with a pre-trained TensorFlow model, which already recognizes shapes and patterns. And the result of this neural network, you can see here in this picture. Now, I would have loved to show you a live demonstration with a drone flying in this very classroom. However, flying drones indoors is quite dangerous. And if you look outside, the weather isn't really drone friendly. So I'm going to introduce you to Florian, Jafar, and Pan, who will show you a live demonstration of our system.
Imagine we're in Benin, and Jafar is flying the aircraft. Pan is the new intern at the LLS rescue team, and it's his first time using the mission operator app. So Pan, Right now on the screen you can see the map in the big view with the aircraft's position. Also in the top right view there's the live footage of our aircraft.
So here is where our aircraft is now.
You can also press on the live footage view to switch it with the map.
Okay, so it seems that we are recognizing all these buildings and roads. Looks cool.
All the image recognition is done on our server and then sent in real time to the app. And we also get sensor data like speed or GPS coordinates.
Oh, wait a moment. I remember there was a flood in this area before. I wonder what exactly happened.
Then let's just go to the historical data view to find out.
Okay, what I'm seeing here,
The blue line is the flight path of the aircraft, and all the labels that you are seeing are the buildings and roads that we are recognizing on our server at the moment. Also, there's a button at the right which you can use to show or hide some of the labels.
I see. So these yellow polygon are those, and we can choose to whether show them or hide them. That's cool. That's good. What about this slider here?
You can use the slider to show all the flight information from different dates.
I see this. What about it disappeared? I wonder if we can compare them more easily.
You can just turn on comparison mode by pressing the button. Then you can see that you have two dots which you can just move to the two flights that you want to compare.
So this what about it did disappear. And we have some new buildings here. I think we need to send a team to further investigate the situation.
Now, to tell you more about what we've achieved so far in the project, it's back to Victor for the status update.
Thank you, Florian. So, during the design review, we had a system with a drone that could transmit video, and we had an image recognition system which could detect buildings. We also had an application which could present the information. However, they weren't really connected. So, since the design review, we've been working hard to connect these three subsystems. And as you could see in the demo, we have a live feed being sent from the drone via image recognition to the application. And hence, I'm happy to announce that we've ticked all the boxes. Despite our hard work, there are still a few things we would like to improve. For instance, we would like to switch to a semantic segmentation model, which would allow pixel-by-pixel image recognition. However, that would require a more sophisticated data gathering. We would also like to test our system together with this aircraft here right next to me. And we were supposed to do that this morning, but due to the weather, we couldn't do it, so we're going to do it in the coming weeks. We would also, as always, like to improve the performance of the system by running it on another hardware or tweaking the algorithms. Now, I would definitely like to invite you all to our booth after the presentation. We have a drone, and we know how to fly it, so you're very much welcome to try it out. And also, I would like to invite the customers for questions. Thank you all.
So first of all, thanks for the team. You did a great job, so what I've seen. So this will be your test aircraft. So hopefully in 2 weeks we don't have snow, so you can try it and fly it on a real one. Beside the use case that we've seen, what would you try to also make as a use case really to use your functionality in that software? Because this is one of the key elements which is currently in the drone business.
Thank you. That's a very good question. We would definitely like to try it out to actually create maps out of the data that we're gathering, because we're gathering where the buildings are, so we should know where to place them on a map, and hence construct a map of the area, which would be very cool.
Which I would also pose as a challenge for you would also to use it in the Alps, because there's always the use case to find somebody who's lost. So especially your algorithm could provide a benefit for such kind of search and rescue teams.
Thank you.
All right, thank you.